Welcome to BEAM-JEE. Now continuing the exercise 3B here, and the next question is the third question in third bit. Let's see third question. Third question. What is third question here? If A is equal 3 minus 4 and 1 minus 1, and then show that a to the power of n is equal to 1 plus 2n minus 4n and n 1 minus 2n for n greater than or equal to 1 for all n greater than or equal to by using mathematical induction. So, by using mathematical induction, so this is the question here. So, solution. If A is equal to 2 by 2 matrix is given, that is 3 minus 4 1 minus 1. And then show that he is asking to find a to the power of n is equal to 1 plus 2n minus 4n n 1 minus 2n for all n greater than or equal to 1. Let's A is equal to, he is given 2 by 2 matrix 3 minus 4 1 minus 1. To prove our condition, to prove that it is a to the power of n is equal to 1 plus 2n minus 4n n 1 minus 2n. We need to prove this one. Let's take if n is equal to 1, if n is equal to 1, take LHS. LHS, that is equal a to the power of n, that is equal, that implies if n is equal to 1, a to the power of 1, that is equal to a. Take RHS from the condition here. Let's substitute n is equal to 1 here. 1 plus 2 into 1 minus 4 into 1 and 1 minus 2 into 1. This will implies 1 plus 2 into 1, that is 3 here, and minus 4 into 1 minus 4 and 1 here, and 1 minus 2, that is minus 1. Here if you observe, if n is equal to 1, we are getting the same as a here. So, it is true. It is true. Then, if I am assuming here, n is equal to k. If n is equal to k, let's substitute n is equal to k. LHS, that will become a to the power of k, and then RHS will become 1 plus 2k and minus 4k and k 1 minus 2k. It is also true. Then n is equal k plus 1, I am taking here k plus 1. LHS, that will become a to the power of k plus 1, that implies a to the power of k into a to the power of 1, that is nothing but a to the power of k into a. Let's substitute the values. A to the power of k into a to the power of k is nothing but, this is the matrix power, a to the power of k 1 plus 2k minus 4k and k 1 minus 2k, and a is nothing but here 3 minus 4 and 1 minus 1. Let's multiply these two matrices here. 1 plus 2k into 3 plus 6k. Directly I am multiplying here. Minus 4k into 1 minus 4k, and 1 plus 2k into minus 4 minus 8k, minus into minus become plus 4k, and k into 3 3k plus 1 minus 2k, 1 minus 2k into 1, 1 minus 2k, and k into minus 4, minus 4k, minus into 1 minus 2k into minus 1. This will become, signs will be changed here, minus 1 plus 2k. Next, 3 plus 6k minus 4k, that is 3 plus 2k. Next, minus 4 minus 8k plus 4k, minus 4 minus 4k, minus 4 minus 4k, and 3k minus 2k, that is k plus 1, and minus 4k plus 2k minus 2k minus 1, minus 2k minus 1. This is can be considered as equation number 1 here. This is equation number 1 here. And let's take RHS here. I am erasing this one here. Let's take RHS. Let's take RHS here. What is RHS? 1 plus, here RHS is nothing but 1 plus 2n minus 4n n 1 minus 2n. This is RHS here, and this is LHS, this is RHS here. There is n is equal to k plus 1. Let's substitute in place of n k plus 1. Then it will become 1 plus 2 into k plus 1 minus 4 into k plus 1 and k 1 minus 2 into k plus 1. Here k plus 1 and 1 plus k plus 1, 2 plus k plus 2 of k plus 1. And let's multiply the terms here. 1 plus 2 into k, 2k plus 2, 2k plus 2 into 1, 2, and minus 4 into k, minus 4k, minus 4 into 1, minus 4, and k plus 1 here, and 1 minus 2k minus 2 into plus 1, minus 2, and again we need to solve this one. 2k plus 1 plus 2, that is 3, 2k plus 3, and the next one minus 4k here, minus 4k minus 4, that is common here, k plus 1 and k plus 1 here. Next, minus 2k, 1 minus 2, minus 1 minus 2k. This is the answer. This is equation number, this is 4, this is equation number 2 here. If you observe equation number 1 and equation number 2, they are same, they are equal here. Therefore, we can write LHS is equal to RHS. Then we can show that a to the power of n is equal to 1 plus 2n minus 4n n minus n 1 minus 2n. This is the solution for this question. If a is equal to 3 minus 4, 1 minus 1, then show that a to the power of n is equal to 1 plus 2n minus 4n n minus n 1 minus 2n for all n greater than or equal to 1. This is all about this question. And the next question is and the next question is third bit, fourth question. Give example of two square matrices A and B of the same order, for which A into B, that is equal to O, but but B into A, that is not equal to O. This is the question here, and here he is given, give example of two square matrices A and B of the same order here, for which AB is equal to O but BA is not equal to O here, and the solution is here. We need to take two square matrices. Give an example of two square matrix A and B of same order. It may be 2 by 2 or 3 by 3, for which AB and the product of these two matrices should be A and B is equal to 0. O is nothing but null matrix, but B and A should not be equal to O. This is the question here, and let's take, I am taking, let A is equal 1 0 0 0 and B is equal 0 0 1 0. These are the two matrices I am taking here of same order 2 by 2, and let's multiply A into B, 1 0 0 0 and 0 0 1 0. Let's multiply the matrices 1 into 0 0, 0 into 1 0, and 1 into 0 0 plus 0 into 0 0, 0 into 0 0 and 0 into 1 0, and 0 0 0 here and 0 into 0 0. All the terms becomes 0 here, then we can say this is a null matrix of order 2, no need to mention there. This is O, this is O here, and let's find BA, B into A. I am taking B matrix here 0 0 1 0 and 1 0 0 0, and let's multiply here 0 into 1 0 and 0 into 0 0 and 0 into 0 0 and 0 into 0 0 and 1 into 1 1 plus 0 into 0 0, 1 into 0 0 and 0 into 0 0. This will imply 0 plus 0 1 plus 0 0. Here this is a one element we got in the product of BA matrix here. So BA is not equal to O. So here the two conditions are satisfied here. These are the two example matrices. When multiply two matrices for A and B will get null matrix, but BA will not get null matrix here. This is all about the solution of this question, and the next question is just look at the next question and read the question once. I am simply reading this question. A trust fund has to invest 30,000 in two different types of bonds. A trust fund has invested 30,000 on two different types of bonds. I am taking X and Y. Two different types of X type of bond and Y type of bonds. On these two invest will become 30,000. The sum of these two invests are 30,000 in two different types. The first bond pays 5% per year. And the second bond pays 7% interest per year. And by using mathematical multiplication determines how to divide 30,000 among in two different types of bonds. If trust fund must obtain annual profit of first one annual profit of 1800 and the second one the annual profit of 2000. Here a trust fund has two different types of bonds. The sum of from these two types of bonds, the total investment is 30,000 and the first one is for 5% interest and the second one is 7% interest. And for annual profit of 1800, for annual profit of 2000, we need to find here. This is the question. I am directly solving here. And the question number is 5 here. The sum of two bonds is, the sum of two bonds, I am taking the first bond is X, first type is X and the second type is Y. No need to mention that. X plus Y is equal to, the sum of two investments is equal to 30,000. This is equation number 1. And the type 1, this is type 1, this is type 2. Type 1, I am representing the information in matrix form. Type 2, here we have two types X and Y. The sum of two investment is 30,000 and for X type 5% is nothing but we can write 5 by 100, and for 5 type the investment is 7%, we can write it as 7 by 100 also. And for type 1, I am writing for X type 5%, for Y type 7%. And for X type, I am taking X and Y here. This is the X type and this is Y type. And I am taking, this is row matrix and this is column matrix, 5 by 100 and 7 by 100. That will gives a profit of 1800 in first case, and in the same pattern will take type 1 and type 2. I am taking a row matrix X type and Y type, and the profits are 5 by 100 first 5% and 7 by 100 7% for the second type. The annual profit for this one is 2000. Here also the same thing, X plus Y is equal to 30,000. So sum of two investments is equal to 30 times. Two types of investment is 30,000. Let's multiply here 5x by 100 plus 7y by 100, that will gives 1800. And let's take the LCM, 5x plus 7y by 100, that is equal to 1800, and 5x plus 7y, that is equal to, if you send this 100 to right hand side, that will become 1,80,000. 1,80,000. This is equation number 2. I am subtracting 2 minus 1, equation 2 minus 1. So 5x plus 7y, that is equal to 1,80,000, and the equation number 1 into 5. Why? Because here if you multiply this equation number with 5, the x term will get cancelled here. So 5x plus 5y, 5 into 30,000, that is 1,50,000. Let's subtract here, the signs will be changed. 5x will get cancelled. 7y minus 5y, that is 2y. 2y is equal to 1,80,000 minus 1,50,000, that is equal to 30,000. Then that implies 2y is equal 30,000 and y is equal 15,000. Y is nothing but 2 1 ja 2 15 ja. Y is equal 15,000 here. And this is all about, and in similarly x plus y is equal 30,000, will get x plus y is equal 30,000, x plus y is equal 30,000. Let x is equal to y is equal 15,000, then we will get x is equal to also 15,000. 15 plus 15, total 30,000. And for the second type, 5x plus 5x by 100 plus 7y by 100, that is equal to 2000. Let's take common here 5x plus 7y, that is equal 2 lakhs. Directly I am writing here. Here this is LCM. I am taking directly to multiplication. This is equation number 3 here. This is equation number 3 here. This is equation number 1. Let's subtract 3 minus 1. 3 minus 1, 5x plus 7y, that is equal 20,000. 2 lakhs, sorry, 2 lakhs, and multiply this equation number 1 with 5x plus 5y, that is equal 1,50,000. Let's subtract the equations. 5x will get cancelled. 7y minus 5y, that is equal to 2y. 2y is equal to 50,000. 2 lakh minus 1,50,000, that is equal to 50,000. 2 1 ja 2, 25 ja, y is equal to 25,000, and x is equal to x plus y is equal to 30,000. Then x is equal x plus 25,000 is equal to 30,000. Then x will become 30,000 minus 25,000, that is equal to 5,000. This is the solution for the question. Two types of investments are there, x plus y. The sum of two investment is 30,000, and the first type of investment is for 5%, and the second type of investment is for 7%. The annual profit for two types are, first one is 1,800 and the second one for 2,000. This is all about the solution of this question, and let's have a look for next exercise. Let us go for the exercise 3C here. 3C, and the first question of 3C is exercise 3C, and the first question of third exercise is, first bit is, if A is equal to, he is given that 2 0 1 and minus 1 5, and B is equal minus 1 0 and 0 1 2, 0 1 minus 2. Then he is asking to find AB dash whole dash, AB dash whole dash. This is the first question is here, and if A is equal to, he is given, that is a matrix of 2 by 3, and B is also he is given 2 by 3, then he is asking to find A B transpose dash is nothing but transpose. The rows of columns of a matrix are interchanged, that is the concept of transpose here. A B transpose whole transpose, A into B transpose whole transpose, this is the question here. Let the first matrix A is equal to 2 0 1 minus 1 1 5, this is the question here. This is the matrix, and B matrix is minus 1 1 0 0 1 minus 2, and let's find B transpose. B dash is nothing but transpose. Transpose is nothing but changing of rows or columns into rows. Minus 1 1 0 0 1 2. I am changing this row to column 1, this R2 with column 2, and this is the matrix of B transpose. Let's find the product of A into B transpose. A into B transpose here. A into B transpose. Let's write the A matrix 0 2 0 1 minus 1 1 5, and multiplication of B transpose 1 1 0 0 1 minus 2. Here the multiplication is possible. Why? Because here 2 by 3 and 3 by 2. 3 will matched here. The final output matrix is 2 by 2 matrix and product is possible here, and I am multiplying here. Next 2 into minus 1 minus 2, 0 into 1 that is 0, directly I am writing 1 into 0 0, 1 into 0 0, 2 into 0 that is 0 plus 0 into 1 that is 0 again, and 1 into minus 2 minus 2. Next minus 1 into 1 minus 1 that will become plus 1, plus 1 into 1 again 1, 5 into 0 that is 0, minus 1 into 0 0, and 1 into 1 that is 1 again, 5 2 ja minus 10, minus 2 plus 0 0 that is minus 2, again 0 plus 0 minus 2, and 1 plus 1 2, and 1 minus 10 that is minus 9. This is the value of A into B transpose. A into, this is the value of A into B transpose, but we require A into B transpose whole transpose. Just we need to transpose of this value, then we will get the A into B transpose whole transpose. Just transport it, dash is nothing but just change the rows into columns or columns into rows. 2 minus 2 2 9. This is the value of A into B dash whole dash. This is a complete solution for the first problem. And the next question is and second question for this one is second question in first bit. If A is equal, he is given minus 2 1 5 0 and minus 1 4, and B is equal, he is given minus 2 3 1 4 0 2, then find, then he is asking to find 2A plus B dash and 3B dash minus A, 3B dash minus A. Here we have a scalar multiplication. The solution is here. He is given, let A is equal 2 minus 2 1 5 0 and minus 1 0, given that B is equal, here this is given that minus 2 3 1 4 0 2, and find 2 into A plus B dash 3B dash minus A. First we need to find B dash. B dash is nothing but this will be, this row is changed to C1 minus 2 3 1 4 0 2. This is B dash, and in both the cases we require only B dash. No need to find A dash here. We require only B dash. That's why I am finding B dash only. And the first condition 2A plus B dash, 2A plus B dash, this implies 2 into scalar multiplication of the first matrix minus 2 into 1 5 into 0 and minus 1 into 4 plus B dash. B dash is nothing but minus 2 4 3 0 1 2, and similarly just you need to multiply this 2 with all the elements in the matrix. 2 into minus 2 minus 4 2, 5 2 ja 10, and 2 into 0 0, and 2 into minus 1 minus 2 2 4 ja 8, and finally you need to write the B dash minus 2 4 3 0 and 1 2. This is B dash. Let's add the corresponding elements of two matrices minus 4 minus 2 minus 6. Directly I am writing 2 plus 4 that is 6, and 10 plus 3 that is 13, 0 plus 0 0, and minus 2 plus 1 minus 1 8 plus 2, 10. This is the solution for 2a plus b dash. The next question is 3b dash minus a. Here the scalar multiplication with b dash. 3 into b dash is minus 2 into 4, 3, 0 and 1, 2. Minus a, minus of a matrix. A is minus 2, 1, 5, 0, minus 1, 4. This implies 3 into minus 2, minus 6, 3 into 4, 12, 3 3 ja 9, 3 into 0, 0 and 3 into 1, 3, 3 2 ja 6. Minus of minus into minus, sorry, just write the terms is simply 5 0. Let's directly subtract here. Minus 6, minus into minus become plus 6 plus 2, minus 6 plus 2, that will gives minus 4 here, and 12 minus 1, 11, 9 minus 5, 4, 0 minus 0, that is 0, and 3 minus into minus become plus 1, 3 plus 1, that is 4 again, and 6 minus 4, that is 2. This is the value of 3b dash minus a. This is all about the second question, and the next question is the next question. First bit, third question. If a is equal 2 minus 4 minus 5 3, then find a plus a dash and a into a dash. This is the question he is given, and the solution for this one. Solution. Given that he is given a 2 by 2 matrix, that is A is equal 2 minus 4 minus 5 3. This is a 2 by 2 matrix, and let's find a dash. A dash for this one. A dash is nothing but transpose, changing of rows into columns or columns into rows. 2 minus 4 minus 5 3. This is the a dash. And the first question is a plus a dash. A plus a dash, that is nothing but 2 minus 4 minus 5 3 plus 2 minus 5 minus 4 3. Let's add the similar terms, corresponding terms here. 2 plus 2, that is 4, and minus 4 minus 5 minus 9, and minus 5 minus 5 minus 4 minus 9 again. 3 plus 3, 6. This is the a solution for a plus a dash, and the next one a into a dash. A into a dash is nothing but 2 minus 4 minus 5 3 into 2 minus 5 minus 4 3. Let's multiply the matrices. Say 2 2 ja 4, directly I am multiplying here. Minus 4 into minus 4 plus 16. And 2 5 ja 2 into minus 5 minus 10, minus 4 into 3 minus 12, and minus 5 into 2 minus 10, 3 into minus 4 minus 12, and minus 5 into minus 5 plus 25, and 3 plus 3 ja 9. Let's solve this matrix here. 4 plus 16, that is 20, and minus 10 minus 12 minus 22, and minus 10 minus 12 minus 22, and minus 25 plus 9, 34. This is the solution for a into a dash. This is all about the third question, and the next question is first bit, fourth question. If A is equal to, is given a matrix 3 by 3 matrix minus 1 2 3 and 2 5 6 3x 7 is a symmetric, then find x. Is given a 3 by 3 matrix here. A is equal to minus 1 2 3 2 5 6 3 x 7 is a symmetric matrix. Find x value here. Symmetric matrix. What is mean by symmetric matrix? Symmetric is nothing but A transpose is equal to A, that is symmetric. If A transpose is equal to minus A, that is skew symmetric matrix. Here symmetric and skew symmetric matrix. Then we can find easily x value, given that the solution is given that A is equal minus 1 2 3 2 5 6 and 3 x 7. Here A transpose is equal to again A. Then find A transpose or A dash, both are same here, A dash, that is equal, this row 1 is changed to C1 minus 1 2 3 and 2 5 6, this R2 is changed to C2 and R3 is changed to C3, 3x7. Now this is the value of A transpose. Symmetric condition. Symmetric matrix is nothing but A transpose is equal to again A. This is the condition for symmetric transpose. If A transpose is equal to A, if you compare the corresponding elements of these two matrices, here A23, this is here. If you compare the corresponding elements of X and if you compare the corresponding elements of X here, X is equal to 6. The X value is 6 here. This is all about the question number 4 here, and the next question is fifth question in first bit. If A is equal 0 to 1 and minus 2 0 minus 2 minus 1 x 0 is skew symmetric matrix, then find x. This is a question here, and given that the solution A is equal to 3 by 3 matrix, that is 0 to 1 and minus 2 0 minus 2 and minus 1 x 0. This is a 3 by 3 matrix. Here he is given the condition is it is a skew symmetric matrix. What is mean by skew symmetric matrix? A transpose is equal to minus of A. A transpose is equal to minus of A, then it is called as a skew symmetric matrix here. Let's find the A transpose here. A transpose for this one 0 to 1, this R1 is changed to C1 and minus 2 0 minus 2 again and minus 1 x 0 here. If you observe this one, A transpose is equal to minus A. If you multiply here, this is a skew symmetric matrix. that is nothing but A transpose is equal to minus of A. Here A in C1 all are positive, here all are negative. 0 is a, if you multiply with any sign, that is 0 only here. Here minus 2, this is plus 2, and this is minus 2, this is x. Here minus 1, this is positive. Here signs are interchanged here. So this is a skew symmetric matrix. After comparing the corresponding elements of x here, the x value is x is equal minus 2. X value is minus 2. Here he is asked to find x value here. And the next question is sixth question. First bit, sixth question, that is 0 1 4 and minus 1 0 7 minus 4 minus 7 0 is symmetric or skew symmetric? Question number. And here the solution is, he is given one 3 by 3 matrix, that is 3 by 3 matrix, given that I am considering this matrix is A 0 1 4 and minus 1 0 7 and minus 4 minus 7 0. Here he is given a 3 by 3 matrix, that is A 0 1 4 minus 1 0 7 minus 4 7 0. He is asking to find, is this symmetric or skew symmetric? Whether it is a symmetric or skew symmetric, he is asking to find. First, if you want to know symmetric or skew symmetric, first we need to find the transpose of a matrix. A transpose is equal to R1 is changed to C1 0 1 4 and R2 is changed to C2 minus 1 0 7 and R3 is changed to C3 minus 4 minus 7 0. Here if you take minus 1 common from this matrix, minus 1, let us write the signs will be changed here, 0 1 4 and 1 minus 1 0 7 and minus 4 minus 7 0. Here if you observe this matrix and this matrix, both are same. This is nothing but A here. Let us substitute this matrix with A, then minus 1 into A, that is equal to minus A. Here after transposing the answer we got A transpose minus of A transpose is equal to minus A transpose is equal to minus A is nothing but it is a skew symmetric matrix. This is all about the solution of this question. In next session we are going to learn the second bit of third exercise. Thank you.